Have you ever stopped to wonder how a simple corn triangle can leave a factory with the same bold color, the same loud crunch, and that seasoning that sticks to your fingers before you even take the first bite? It may look like just another snack, but behind every bag of Doritos, there is a massive chain involving endless fields, enormous harvesters, corn-loaded trucks, towering silos, and high-speed cutting machines. And all of it works like a true industrial symphony. Machines, sensors, conveyors, and packaging systems moving in perfect rhythm to prepare tough bags, designed to protect every crunchy chip until it reaches store shelves. Welcome to Factories and Facts. Today, we are going to uncover how Doritos begin in the field, pass through giant machines, and become one of the most recognizable snacks on the planet. And the most fascinating part is that almost nothing in this process happens by accident. The triangular shape, the thickness of the dough, the frying time, the amount of seasoning, and even the nitrogen gas inside the bag are all part of an engineering process designed to create the same experience millions of times. And you heard that right. That air inside the bag, which many people think is there just to make the package look fuller, actually serves an important purpose. In many snacks, that space is filled with nitrogen, a gas that helps reduce contact with oxygen and protects the crunch, keeping Doritos from reaching the customer stale and limp. But the big question is, how does corn, which begins as a simple ear in a cornfield, become that orange, crunchy, addictive chip? One that almost seems designed to make noise? The answer starts long before the colorful bag. It starts in the soil, in the weather, in the harvest, and in a strict selection of the kernels. And if in the previous episode, you saw how Coca-Cola depends on blending, pressure, bottling, and a formula wrapped in mystery, here the logic is different. The secret does not begin as a liquid inside tanks. It begins with millions of corn kernels moving through a massive agricultural chain before becoming a snack. So make sure you are subscribed here to Factories and Facts, because now you are about to see that the real secret of Doritos is not just in the seasoning. It begins in the impressive journey corn takes before it ever enters the factory. And can any type of corn become Doritos? Or is there a special kind chosen to survive this transformation? Stay with me and let's find out. Before any crunchy triangle drops into a bag, there is a landscape most people never associate with Doritos. Miles of cornfields, perfectly aligned green rows, and massive farm machines rolling forward like giants on wheels. That is where, far from store shelves and colorful packaging, the story begins of a snack that looks simple but depends on a huge agricultural chain to exist. The corn used in this kind of production has to arrive with very controlled characteristics. It is not enough to harvest just any ear of corn and send everything to the factory. The kernel needs a strong structure, the right moisture level, plenty of starch, and enough resistance to go through cooking, grinding, dough formation, cutting, frying, and seasoning without losing consistency. Think of corn as the foundation of a building. If the base is weak, too wet, or uneven, everything that comes after starts to run into problems. Out in the fields, everything begins months before the factory enters the picture. The soil is prepared, seeds are placed by planters that move down long rows with precision, and each row has to grow with the right spacing to receive sunlight, water, and nutrients. Seen from above, a cornfield looks like a giant geometric design, with green corridors repeating as far as the camera can reach. And it is incredible to imagine that part of this ocean of plants may end up becoming triangular chips inside millions of bags. As it grows, the plant rises, thickens its stalk, opens wide leaves, and begins forming ears protected by husks. Inside each ear, hundreds of kernels develop side by side, building up starch and gaining firmness. At this stage, the weather can help or disrupt everything. Too much rain makes drying harder. Extreme heat can damage development, and a lack of water reduces the size of the kernels. For someone buying the finished bag, all of this feels far away. But for the industry, every detail in the field can later show up in the texture of the chips. When harvest time arrives, the scene changes completely. Combines enter the cornfields like monumental machines. At the front, a special header grabs the rows of corn, pulls in the plants, separates the ears, and carries everything into the equipment. In just seconds, what was attached to the stalk is shelled, cleaned, and separated. The kernels move into the machine's grain tank, while husks, stalks, and plant residue return to the field. And here is one of the most powerful scenes in this entire chain. When the combine's tank fills up, a side auger pours a stream of golden kernels into a grain cart or truck moving alongside it. The corn falls like a solid waterfall, forming yellow mountains in the bed, while dust, dry husks, and sunlight create an almost cinematic image. This is the moment when the raw material leaves the field and starts moving closer to the factory. After the harvest, the corn moves on to storage facilities, elevators, or receiving centers. There, samples may be tested to check moisture, impurities, broken kernels, and overall appearance. If the corn is too wet, it can ferment, mold, or lose quality in storage. If it is too dry or brittle, it can create problems during grinding. The goal is to keep the kernels stable, clean, and predictable, because the factory has to run like clockwork. Imagine a truck unloading tons of corn into a receiving pit, that large metal opening in the ground. The bed tilts. The kernels slide down in an avalanche and disappear through heavy-duty grates. From there, bucket elevators, screw conveyors, and belts carry the corn into cleaning systems. Vibrating screens remove pieces of husk, dust, small stones, and unwanted fragments. Before it becomes industrial food, the corn has to leave behind everything that does not belong in the process. Next comes a part consumers rarely see, but it is essential: storage in silos. These giant cylinders work like vaults for raw material. Inside them, the corn has to be protected from moisture, excessive heat, and pests. It is monitored because a mass of corn stored the wrong way can heat up, deteriorate, and compromise entire batches. This is where the process reveals a hidden truth. Doritos do not depend only on seasoning. They depend on agriculture, transportation, cleaning, storage, and quality control on a massive scale. A small bag carries the story of tractors, planters, combines, trucks, scales, labs, and silos. All of this happens before the factory forms the first crunchy triangle. When the corn finally moves to the production facility, it may still go through another round of cleaning and sorting. The factory has to reduce variation in the raw material as much as possible, because heavily damaged kernels, excess dust, or impurities interfere with the dough. And the dough is the heart of Doritos. It has to be firm enough not to break before packaging, but light enough to snap in your mouth. From this point on, the corn begins to stop being just a kernel. In tortilla chip processes, it is often cooked in water with an alkaline agent, a technique associated with nixtamalization. This treatment helps modify the structure of the kernel, makes grinding easier, and contributes to forming a more suitable dough. It is an ancient technology, but inside the industry, it gains steel tanks, time control, temperature control, and precise proportions. Visually, the scene changes again. The cornfields disappear, and pipes, valves, steam, and metal equipment take over. The corn, once dry and golden, goes through controlled hydration and cooking. If it is undercooked, it stays hard and difficult to grind. If it is overcooked, it loses structure and damages the cut. The factory works on a narrow line between the ideal point and waste. Then, the softened kernels move into grinding. Little by little, they stop looking like corn and become a thick, moist, grainy dough. This is the dough that will carry the identity of Doritos. Many people imagine a triangular snack is born from some artificial mixture shaped out of nothing, but the foundation of the process is more direct. Corn that has been prepared, cooked, ground, and transformed into a dough that machines can work with. The texture has to be just right. If the dough is too wet, it sticks to the equipment, deforms during cutting, and absorbs oil unevenly. If it is too dry, it cracks and breaks too early. That is why operators and control systems track how the mixture behaves. In a large factory, there is no room for improvisation. The standard has to repeat batch after batch. Now comes the question. After this entire journey, how does a heavy, shapeless dough turn into thousands of identical triangles per minute? That is what we will see now, when the corn finally takes the shape everyone recognizes before even opening the bag. The corn dough comes out of grinding wet, heavy, and plain. At this point, it still does not look like Doritos. It has no bold color, no crunch, no signature seasoning, and certainly not that triangular shape everyone recognizes. But this is where the factory begins turning a corn paste into thousands of nearly identical chips. First, this dough moves into equipment that controls its thickness. Imagine two large metal rollers pressing the material like a rolling pin, only on an industrial scale, with conveyors, sensors, and constant adjustments. If the sheet is too thick, the chip can come out hard and heavy. If it is too thin, it breaks before it ever reaches the bag. It may seem like a small detail, but this thickness helps define the sound of the bite and the strength of the snack. Once leveled, the dough becomes a continuous sheet. It passes through cutters that stamp the triangular pattern at high speed. In just seconds, a smooth surface turns into a sequence of small, pale triangles, still raw and fragile. They already have the shape of Doritos, but they do not yet have the personality of the finished product. But why triangles? The shape is not just about looks. The points and edges increase the feeling of crunch, help the chips seem sturdier, and create such a strong visual identity that many people recognize the product even without seeing the bag. The triangle has become an industrial signature. At this stage, the factory has to maintain a constant flow. The cut pieces move along conveyors, but they are still soft and sensitive. If the dough is too wet, it can stick to the equipment. If it is too dry, it can crack. If the conveyor vibrates more than necessary, the chips can deform. Everything has to happen at the right rhythm, because a stopped or misadjusted line quickly creates waste. The cutting scraps can be reused within the process, depending on the system being used. But even that requires control. If too much dough returns to the cycle, the texture can change and affect the next batch. The industry does not just want to produce a lot. It has to produce the same result every time. This is also where a common myth falls apart. Many people imagine Doritos are already orange and packed with flavor right from the dough. But at this stage, the triangles are still pale, raw, and almost bland. The bold color, the strong aroma, and the seasoning that sticks to your fingers come later. Before that, the chip has to gain structure. Now comes the delicate part, preparing these triangles for heat. If a piece comes out uneven, it can fry unevenly. If it is too wet, it absorbs too much oil. If it is brittle, it turns into crumbs before receiving seasoning. That is why forming the triangle is not just visual. It is the moment when the factory decides whether that dough can survive the next stages. In just seconds, the corn stops being a shapeless mass and begins traveling along the conveyor as a crowd of perfectly cut triangles. But they are still far from the Doritos that reach the market. They are missing the blast of heat, the crunch, and the layer of flavor that turns a simple chip into a snack you cannot ignore. And now the factory becomes more intense. Hot oil, fast conveyors, sensors, sprayed seasoning, and quality control working so every Doritos chip comes out crunchy, colorful, and packed with flavor. Now the triangles enter the most intense phase of the factory. Up to this point, they are still pale, fragile, and almost bland. But when they meet the heat, the dough loses moisture, gains structure, and begins turning into the crunchy chip people recognize. Industrial frying requires precision. Temperature, time, and conveyor speed all have to work together. Visually, this stage is hypnotic. The triangles go in pale, move through bubbling oil, and come out firmer, golden, and lighter. Steam escapes, moisture drops, and the crunch is born. Right after that, excess oil is reduced by conveyors, vibrations, or drainage systems. The ideal bite has to be dry, crunchy, and light. And only now comes the big secret: the seasoning. The chips enter rotating drums or application systems, where they receive a powdered blend spread across the surface. This powder has to reach the faces, edges, and points, creating that signature layer that sticks to your fingers. The chip's surface, still warm and carrying traces of oil, helps the seasoning adhere. If the chip is too cold, the powder does not stick well. If there is too much oil, the flavor feels heavy. If there is too little seasoning, the customer notices it on the first bite. The seasoning drum works like a controlled avalanche. As it rotates, the chips fall, roll, and mix. The powder is applied at calculated points, and each movement helps spread flavor more evenly. But how do you know everything is right at that speed? That is where quality control comes in. Samples may check color, texture, flavor, weight, moisture, and breakage level. Sensors and cameras can also identify chips that are too dark, too light, misshapen, or outside the standard. Color reveals a lot. A pale chip may indicate insufficient frying. A chip that is too dark may indicate too much heat or too much time. Crunch is also monitored because it depends on final moisture, dough thickness, frying, and cooling. Another critical point is breakage. The triangular shape has points, and points break easily when the process is out of balance. If the dough was weak, if frying made the chip brittle, or if drops along the conveyor are too harsh, the bag can arrive full of broken pieces. Before packaging, broken, burnt, or misshapen chips can be removed. The customer sees a colorful bag. The factory sees size, weight, color, crunch, flavor, and integrity. If you are enjoying discovering how a simple snack requires so much industrial precision, leave a like on this video. It helps Factories and Facts bring you more behind-the-scenes looks at factories and processes that almost nobody gets to see up close. Now the Doritos finally have shape, color, crunch, and seasoning. But all of that still has to be protected until it reaches the shelf. That is when the packaging machines, the gas inside the bags, the boxes, the pallets, and the final journey to the store enter the story. Now that Doritos have their shape, crunch, color, and seasoning, one decisive step remains: protecting all of that until it reaches the customer. Because a chip can come out of the fryer perfectly, but it can still break, go stale, or lose its aroma if the packaging fails. First, the chips travel by conveyor to automatic weighers. These machines divide the product into exact portions, calculating the weight of each bag at high speed. It is not a person scooping snacks by hand. These are systems that combine small amounts of chips until they reach the correct weight, reducing overfill and preventing underfilled bags. Then, the Doritos drop into bags formed by vertical packaging machines. The plastic film unwinds, forms into a tube, receives the portion of chips, and is sealed in fractions of a second. The bag has to be strong, lightweight, and tightly sealed because it works like armor against air, moisture, light, and impact. And you know that empty space inside the bag? Well, a lot of people think it is just a trick, but it also helps protect the chips. In snack bags, the package often receives a protective gas, usually nitrogen. It reduces the presence of oxygen and helps preserve crunch and aroma. On top of that, this internal cushion helps reduce breakage during shipping and stacking. Next, the bags are grouped into cases, which move on to pallets. The pallets are wrapped in plastic film, and everything enters the distribution network. Trucks carry the product to warehouses, grocery stores, wholesale clubs, and convenience stores. The journey that began in a cornfield ends on a shelf, where the customer sees only a colorful bag. And that is why this process is so impressive. A Doritos chip is not just corn, oil, and seasoning. It is the result of large-scale agriculture, mechanized harvesting, giant silos, grinding, controlled dough, precise cutting, frying, flavor application, sealing machines, and logistics. Every triangle carries a true industrial journey. And one impressive detail is that the triangular shape helps make the product recognizable before the first bite. The industry does not sell only flavor. It sells sound, texture, color, smell, shape, and memory. That is why, when someone opens a bag, the brain is already expecting that loud crunch and the bold seasoning on the fingers. Now tell me in the comments, which part of this process surprised you the most? Was it the corn harvest, the silos, the triangle cutting, the seasoning, or the gas inside the bag? And also tell us your city and state, because it is always fascinating to see where the Factories and Facts community is watching from. And if you enjoyed discovering how Doritos are made, subscribe here to Factories and Facts. Here we reveal the behind-the-scenes world of factories, machines, and processes that turn everyday products into industrial spectacles. And if you think you have seen it all, then you cannot imagine the factory we showed in our last episode. It is already appearing on your screen right now. Click it, and come with me to discover another hidden secret here on Factories and Facts. A big hug. I'll see you there.